Good afternoon, everyone. My name is Zhang Qian from Shanghai JiaoTong University. I'm very honored to present our work, Write, Attend, and Spell, Streaming End-to-End Freestyle Handwriting Recognition using Smartwatches. Smartwatch is emerging as the most popular wearable devices in recent years. It offers great convenience to users through a wide range of on-the-go applications, such as checking emails, writing notes, messaging, and social networking. Touch input as the primary input form for smartwatch is limited by the small screen size. Systems aiming to facilitate touch input, such as finger identification, impose burdens on users to adapt to new touch methods. Voice input can be a promising alternative, but it is not suitable in some public settings such as meetings or noisy environments. In this paper, we turn our attention to the traditional handwriting methods. We propose Write, Attend, and Spell, a word-level text entry system for smartwatch that enables freestyle handwriting recognition. We leverage initial sensors in the smartwatch to capture the head movements of users when they write on surface with their indexed fingers. Unlike previous methods, WriteAS enables word-level recognition in a streaming end-to-end way. Here is the system design, which consists of three modules: data collection, signal preprocessing, and handwriting recognition. In data collection, we leverage multiple sensors including accelerometer, gyroscope, and gravity sensor to capture the head movements. In WriteAS, we adopt a lightweight method, which is computing the energy level of motion signals to detect the writing behavior. Then we employ a multimodal CNN to learn intramodality and cross-modality representations hierarchically. There are three branches for each sensor, which are used for intramodality feature extraction. Afterwards, we adopt a merged CNN to extract cross-modality features. In word-level recognition, since it's hard to segment for each letter, we treat the word-level handwriting recognition as a sequence modeling problem and adopt an encoder-decoder network to directly map the sensor signals into words in an end-to-end way. In order to improve the user experience, we also add a CTC decoder on top of the encoder to output each letter in a streaming way, so as to realize real-time feedback. The next part is the implementation and evaluation. We develop a data collection prototype on Azure smartwatch. We invite 12 volunteers for data collection. Here is our dataset details. In user-independent settings, we can see that our system achieves a very high performance. Then, in user-independent test, everyone's CEI is lower than 15%. Although the word accuracy seems not very high, the result is still very impressive considering that the testing user is not in the training set, and the writing behaviors of different users differ a lot. We also evaluate the performance in translating unseen words, and there is no public and large-scale dataset for smartwatch-based handwriting recognition. The recognition ability for unseen words can eliminate the burden to collect all possible words. The results show that WriteAS can effectively recognize unseen words. Then we evaluate various word-level micro benchmarks under the user-independent test and unseen word test. These benchmarks include different initial signals, different encoder models, and different end-to-end network. We also evaluate the performance with an external language model. Due to our limited word set, the language model learned by the attention-based decoder barely helps on the recognition of unseen words, where the external language model will make a big difference, especially to the word accuracy. And last, we carry out the system delay impact of watch model and writing surface evaluation. Results show the robustness and effectiveness of WriteAS under various settings. We also perform user survey. We first compare our system with two commonly used smartwatch input methods. WriteAS achieves the highest ratings on nearly all the dimensions. In addition, volunteers rate WriteAS very positively on our questionnaire about the user experience. Here's our conclusion. First, we propose WriteAS, a universal end-to-end handwriting recognition system for smartwatch, which is reliable and robust under different writing behaviors. Second, we adopt a multitask encoder-decoder network to enable streaming end-to-end word recognition, which gets around the letter segmentation and allows users to write in a cursive and continuous way. Third, we construct a high-quality dataset and achieve impressive performance on a broad range of evaluations. That's all of my talk. Thanks for listening.